Great, thanks. Welcome everyone. Yeah, so I'm Jeff Saunders. For this talk, I just took a piece out of, I teach a course as part of the Common Core program, and these are interdisciplinary classes that everyone has to take. So I teach one of those, and for this lecture, I took a portion of that content out. So that's what you're gonna get today. And the course I do is on irrational thinking, and this is one subtopic that I kind of extracted. And I want to start with an example. All right, why are we talking about the tongue? But has anyone heard of this before? All right, so I've got some hands out there because I had heard of this too. There's this idea that the tongue has different receptors. So we know we've got different kind of taste receptors for sweet and salty. And the idea is that they're not even on the tongue, so different portions would have different things. So you've got front sweet, back bitter. All right, so a number of you are familiar with this idea. If you Google a tongue map, you can find things. I found someone in Hong Kong, the wine guy, talking about how your experience of wine will be affected by how the wine passes different parts of your tongue. This is actually something you could test pretty easily. I mean, how could you test this? It wouldn't be that hard. You could take something that's sweet and put it on different parts of the tongue, right? You could take something sour. So it's actually pretty easy to do. You just apply some different flavors, see where you can taste or you can't. And in fact, it's a demo for education. For example, PBS Zoom activities, neuroscience for kids, University of Washington, have descriptions how to do these kind of things, right? The only problem is that this is completely wrong. There is no tongue map. This is just purely a myth. So I think that's kind of interesting here, and this is an example of kind of something where people think they know something or gets passed on, and why would it still be around? In fact, all your taste receptors are evenly distributed. It's not true at all. There's little difference in sensitivity across the tongue, and if there is, it's just kind of random. It's not systematic. So it's just wrong. And this is not a recent finding. There is research on this. You might think, who would be studying this? But in fact, there's a whole areas of research on taste and smell that's very important for industrial purposes and constructing flavors. So we know a lot actually about the process of detecting sensors on your tongue and the neuroscience. And this idea isn't anywhere in the scientific literature. There was a randomly a study from 1901 that had an evocative picture, and somehow that got this ball rolling, right? This wouldn't even be an issue for most things because we know so much more about it. It just is not a factor. There's also many news articles debunking this myth. At the time I made the slide, I found a couple. So if you search tongue map, you can find bad information. If you search tongue map myth, you can find lots of debunking. So they're both plenty available out there. So, and I find it surprising. I've actually got no reply to some people still putting these activities for kids. But this is just one example, but I was kind of using it as something that there may be a lot of things out there in the culture that are not true that we think we know. So that's why I call this How We Know What Isn't So, and that isn't me being creative. I took that from a book that I use for teaching called this by Thomas Gilovich. And he was inspired by a quote, "It ain't so much the things we know that get us in trouble, it's the things we know that just ain't so." The things that aren't true that we think we know can be more of a problem. And that's why I want to talk a little bit about why you get these and why they persist. And especially about cognitive factors. Because of course, if someone tells you something that's wrong, you read it, that'll get passed on. But why isn't these things get corrected better? So it could always be, you hear something wrong, it's broadcasted, yeah, that might propagate. But there's some other factors that make it hard to correct this. And this is part of the reason I present this thing is interesting. It can be easily tested. And in fact, it's been tested many times. The fact that it's a science experiment for kids means like people have done this and encountered the failure repeatedly. Yet this myth is still out there. Every time it's not going to work because it's not true, right? So how could this persist? And you could ask the same question about other kinds of common myths we have these days. And you can imagine if you tried this demo, you could try it on a friend now, just for fun and see how it works. Why might the rules appear to support the theory? And there's, expectations might influence your perception. Maybe I think I taste a little more salty because I expect it, maybe a little less salty. Or maybe it's inconsistent, but you're thinking, is there another explanation for this? Maybe I did it wrong. Maybe different individuals are different. Could be problems with the test. Maybe I didn't, right? So I'll come back to these points a little more detail, but there's reasons that maybe it's not that easy to correct things once they go off, right? So that's what I want to talk about here is why would erroneous beliefs persist? So once we have something, in principle, if we start getting experience and the world doesn't match it, because it's false, then maybe we'd start to learn it's not true. But it's not that easy because some circumstances and cognitive tendencies work against this. And a couple factors I'll talk about today. All evidence isn't equal. There are sometimes asymmetries in evidence to where the things that might help you learn something's not true might be the ones we notice or pay attention to or called attention. So that's one factor. And it doesn't help that we also sometimes make it worse by trying to seek confirmation rather than kind of seeking information in a balanced way. And finally, even if we have the information available and noticed, we may interpret it in biased ways. So these are all add together to make the problem kind of difficult. So I'm going to go a little bit and show some examples for each of these things I've talked about. So the salience of evidence. Let's say I think my roommate is irresponsible about doing the dishes, right? So here's what I think is true. You're going to have lots of evidence as your roommate every day. There's another case where either they wash the dishes or not. But then you could ask which cases will be noticed. So Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. Oh, So point being, I mean, look, maybe I've encountered lots of cases here. Each one's a piece of evidence, but they're not equal. These ones, am I thinking about whether the roommate was responsible for washing dishes? No, I'm going about my business, making my meal and thinking about other things. It's only this one where I'm going to be drawing attention to this fact, right? It is the one that stopped you. So these are non-events. Even if it's very frequent, it's all cleaned up nicely. Maybe they're not even noticed. You're going out about your business, but that's the one that's going to stick out. So your roommate could be thinking it's completely unfair. I'm really good. And you could be thinking roommate's very irresponsible. And you both would feel like you had evidence to back that, right? The roommate remembers all the time they wash it. You're more likely to remember the times where something's interfered with you and stuck out, right? And that's common in a lot of situations, the evidence, things that are events or not events, or something that's causing you trouble or not. In this case, the wash dishes, the positive and negative are not equally noticeable. Certain things, this could also get started believing this happens a lot, even if it doesn't. But especially once you got an idea, it's going to be reinforced just because the evidence isn't equal. Other things like this, if you feel like you have bad luck and always choose the wrong line, that could be something like, well, the times you choose the bad line are the ones you notice, right? The same idea. I'll give you one more example. Being a psychology professor gives you some psychic powers, if you didn't know. And I want to make a specific prediction. On the first day of Lunar New Year next year, there will be a major earthquake in China. So this is actually a fairly specific, falsifiable prediction, right? They don't happen that often. So would this be a good test of my psychic ability? Well, most likely there will be no earthquake because it is an unusual case. So that's most of the case. And in that case, are you going to remember I talked about this at all? This is like one little piece of info day, right? That you're going to hear a lot of things. So that's not going to stick out particularly. So I can put this out there, the prediction, and if it doesn't come true, no one's going to email me later saying, you're not a psychic after all. But on the off chance that this happened, this would really stick out. So if I want to convince people I was prophetic, I could go put a whole bunch of these out there. And maybe all those failures are out there, but then the few times there's a hit would really stick out. And this is similar. It's another example of the same idea about the dirty dishes thing, that all these evidence is not equal. And that could allow you to think that to some relation that isn't true or support something. So we've got something, these aren't equal. One is an event, one's unusual, surprising, one isn't. They're not equals. So you're not necessarily getting all the equal experience. All right, what about seeking information? Let's do a little task here. We're going to try and figure out there's a rule, this kind of a rule that some sets of 3 numbers satisfy. Some satisfy, some don't. And we're going to try and figure out what it is. And I'll start off. Here's one example. 2, 4, 6 satisfies the rule. Right? Now you asked me for some other, give me examples of other combinations. I'll tell you if they satisfy. So 2, 4, 6 is a yes. Someone in the front, you, what are 3 other numbers to try? 14, 16, 18. All right, 14, 16, 18. Does that satisfy the rule? Yes, it does. Okay, now somebody else give me one. How about you? 20, 22, and 24. Guys, why'd you pick that one? Ah, you're thinking maybe it's adding 2 numbers. This is a yes. That is also good. All right. Someone else. Yep. 1, 2, 3. Okay. 1, 2, 3. That also satisfies. Ah, right. All right. How about one more? Let's see. Yes. 1, 3, 5. That also satisfies. Do you have an idea what it is now? What? -3, -2, -1. That's a yes too. What do you think it is? Yes, back there. All right, someone thought it's always increasing. Other ideas what it is? All right. It actually is just increasing numbers, but early on, people were thinking it's increasing by 2, right? So, and the interesting thing about this demo is what people choose when they have their ideas. So I start off with 2, 4, 6. There's a lot of patterns in that. It could be increasing by 2s or it could be equal multiples. So it's easy to kind of think, I've got some idea to start with. And what tends to happen is if people think it's advanced by 2s, they do other examples that advance by 2. And then like, oh, maybe it's not. Oh, now it's like, I got to revise it. Maybe it's even steps. But the interesting thing is that once you think it's advanced by 2, you could have jumped immediately to this, or 1, 4, 7, 1, 9, 6, right? And whenever I do this, usually it takes a while before someone finally does this. You get in mind, your head, there's some rule, and then every time you get a positive, it feels a little reinforcing, like, ah, there's another one that was right. But really, if you thought it was the evil steps of 2, that might have been a good thing to do. Because now this should have been a no. And there's just a tendency, it doesn't always work. Sometimes I have people go straight for that one, and then it kind of spoils the demo a little. But usually I get something like this pattern where people kind of have an idea what it is, and they keep asking for one of the same pattern, right? So this is kind of, so here I already wrote like the typical pattern, 2, 4, 6, yes, and then maybe 4, doing one similar ones. And then finally get one that's it's set you change. So the point of this is that if you're really trying to figure this out, you might want to quickly, once you have an idea, go for the one that wouldn't work. That would help rule some things out. But they're just kind of not our tendency. If I think it's even multiple of 2, then maybe I want to go for another one of those. And what can happen is it can go a few times before people actually figure it out. So this is an example. There's rule discovery, the initial example chosen so that you might have some guess. And then the cognitive effect we're showing is your tendency to look for positive things that would confirm it, things that you think are going to be a yes. And the problem there is that you didn't get an opportunity to learn your guess was wrong. Until you do the other one, you don't learn it. And you may feel more and more confident because you keep getting these nice confirmatory ones, right? So this is example, this has been called a confirmation bias. You may have heard of that. Confirmation bias, a term that's used for this kind of thing, and also something I'll talk about later. So a bias in seeking information and also a bias in how you interpret information. So this is a bias toward confirmation, looking for other examples that are consistent with what you expect. Here, let's try one more. Now that I've covered this, I don't know if this will work as well, but suppose we wanted to make some items for an extroversion scale. In scales in psychology, they're often done where they're Likert scales, where they're self-referential statements. You may have run into this. It's statements that could be about you or not, and you rate whether you strongly agree or disagree, right? I won't have everyone do it, but like, let me get some volunteers to give me a statement. We want a scale for extroversion. What's a statement you could have on it? I enjoy getting out with friends. That's great. So extroversion is about social, so good. I enjoy getting out with friends. Let's have another one. Someone over here. Somebody give me another example. I enjoy time alone. Okay, good. Let's have two more. Scale for extroversion. Give me an example. What? Animals. Okay. All right. All right. This one isn't working as well, but all right. So your question was, I really enjoy getting out with people. If you're an extrovert, you'd say yes. You said, interestingly, I enjoy alone time, right? Then extroverts say, no, that actually is good. The effect I usually get is I get lots of yes questions. So people tend to do lots of, I enjoy going to parties, I'm off for the life of the party, and I usually will have like at least 75%, 80% yeses and very few nos. But you had a good idea to actually go the other direction, because if you want to learn about extroversion, you could have positive or negative coded. But the natural tendency, I'm thinking of extroverts, I'm going to make a question for the scale. What are extroverts like? They're talkative, they have a lot of friends, they go to parties, all that stuff's up there. But again, it's kind of ignoring the negative side. All right, so this one didn't work, but the tendency usually, especially if I can sample it bigger and have a little time, is to get more agree items. So that would also be a bias in seeking information. Another example, like that rule discovery with the 246. One more example. This is a little bit of a toy example, but one more, it's kind of a classic. So my hypothesis is that cards, so there are a bunch of cards that have a number on one side, a shape on the other. And I want to know, if cards have an odd number on one side, do they always have a circle on the other? And here's the cards. Which ones do I have to flip to tell if this is true? Who thinks I have to flip this card? I agree with you. We want to flip this because it better have a circle on the other side. Who thinks we need to flip this? Anybody? Who thinks we need to flip this? Aha, we got a few people think this. And how many people think we need to do the square? All right, so those are the tricky ones. And a lot of people said circle. Some people said square. If you really wanted to do it, this is a common answer. And I just saw that in the handholds. It's kind of obvious that threes needed to be flipped. And then circle, if you flip that and see an odd, it would support the idea. But really, you need a D more than C. Because what if we flip that square and it turned out to be a 5? Oh, sorry, that's okay. Oh, yeah, that's a problem, right? And this one's much less obvious to see that that's necessary. No, right? So we do this, we're thinking of, again, this has been interpreted as a confirmation bias. You flip this and see a 5. Oh, that's great, I'm getting more evidence. Not as obvious that we need to do that. We may neglect that a little bit, even though that's what we need to do. Kind of like how if you got an idea what the rule is, maybe you need to do 196 or something. Same thing going on here. It's just not that obvious, right? So two of them are easy, but then these two are the tricky ones, right? You flip this over and it's odd. Yay, right, it supports. You flip it over, it's even. Well, who cares? I didn't say anything about even. So So this is another one that's called the Wason selection task. Logically, you need to check those two, but people get tempted to that one, and that's also kind of confirmation bias. So when we are evaluating a belief or value, we tend to focus on the confirmation and seek it, and that's another reason we might not be exposed to a broad range. So I first talked about how some might be more noticeable than others, but also we're not passive. We may go looking for information, and that's not unbiased either. And these three, all kind of toy examples, but you can imagine this could apply in the real world too, when you're looking at information about something rather than just kind of this play task. Oh yeah, I've still got a good time. All right, and now this is kind of other work kind of about the availability of information. And now I want to talk a little about how you interpret evidence, and how what you believe or your expectations can influence things. And it can have influence both as biasing ambiguous or affecting how you interpret unambiguous. Sometimes when if we have to make a judgment, the information is not all that clear, and that leaves a lot of room for influence from what you already expect. Maybe if something's going by really fast, you have to evaluate as a high tackle or not. I mean, that should be objective, but maybe it's a little hard to tell. And now we throw in, I don't know, are you a fan of one team or the other? Is that going to be completely ignored if you're evaluating that, if the information has ambiguity? And actually, I use the example. There is a study, it's a little older, but by Frank and Gilovich. They looked at referees making judgments about penalties, and they varied the color of the uniforms. This is experienced referees, if I remember. They evaluated possible penalties from videos. I'm showing hockey, but the actual was American football, and they staged scenes to like make a penalty happen with black or white jerseys, and they did the same ones to try and make identical except for the jersey color. If you do it today, you'd probably just do some computer things to switch the color so you wouldn't have to stage, but this is back in the 80s. So identical situations except varied in uniform color. Right? Then there have people rate, was there a penalty in this or not? This might seem a little weird. So everything is the same except for uniform color. If you're an experienced referee, why would that have some effect? But actually, they found that more penalties awarded for the people wearing black, right? So in your experience, and you're looking for, you've got specific things to look for, but maybe it's not always clear cut. You know, people are trying to do the task. There's probably some examples that are clear cut. They're not going to make mistakes on the color of jersey won't matter. But maybe some of the times it's not so clear cut. And now there's an avenue for your bias to work in if you're expecting something. And the reason black-white is their idea was we have a stereotype as black as the color of the bad guy. So with that background knowledge, it may influence you just a little bit once the situation's ambiguous. So that could have some effect. And if I go back to the tongue map, this could be a factor. You're expecting, it could influence, like maybe you're not supposed to taste sweet in the back, say, and you still taste sweet, but maybe you can think it doesn't taste as sweet. Something about your expectations might affect how you judge that. It's possible that that could be contributing. You've got trusted source telling you this is true. Perception is not 100% determined by the objective stimuli. A lot of your expectations and experience can influence that. So that could be part of what's going on with the tongue map. I don't think that's the whole story, but it could be something. What happens if it's more clear? So we have the psychic fair was canceled due to unforeseen circumstances, right? So sometimes it might be very clear the evidence seems to be going against. What do we do then? There are possibilities. Do we simply accept the evidence? That's a little optimistic and maybe not a little naive too, because we wouldn't necessarily want to immediately drop our belief. So probably not. Would we ignore it entirely? I mean, that could be one way. I'm going to preserve my beliefs by I didn't hear it, but probably not. That's not very natural for us either. Are we going to misperceive it? Distort our understanding? So those, I kind of usually, these aren't the kind of things we do. That's not realistic about if we're encounter something that seems to contradict something we think is true. The expectations do exert bias, but it's not a perception bias or memory bias. So what do people tend to do? Tend to apply selective scrutiny. And this has also been termed a confirmation bias. It's a little different thing, but it's about scrutiny, meaning that if the evidence is something consistent with what we already thought, great. I don't have to think about that. That just fits in my worldview fine. But if it's something that's inconsistent, then there'll be naturally a tendency to want to explain it away. Think about, is there some way I could explain this without revising? And this may sound like, oh, this is bad, but this is actually pretty natural. There's a lot of things we know that are true. We don't necessarily want to be revising what we think about the world super easily. We encounter something that seems to change what we believe. It's not bad to think about. Maybe it could be interpreted some different way. Right? The issue is that when we do have something we believe wrong, this could get in the way because we're not giving the same scrutiny to things we already think are true. I'll give you, this is supported by some research. I'll give you a couple examples. Well, maybe just one, but given a study of conversations of gamblers about wins versus losses, and to find out, so people gamble a lot. They maybe have misconceptions about how often they're going to win, or so do they have a memory bias or perceptual bias? Well, if people are persisting in this behavior that's pretty unhealthy, especially long term, is it because they're misremembering? They think they lose less than they really do. Maybe they don't remember it as much. They don't focus on it as much. Or is it something else? And in fact, they found there was more discussion and analysis of the losses than the wins. So in their memory, so they weren't like ignoring all the losses. But what they found in the conversations was they were interpreted in systematically different ways. So the wins were, the outcome were perceived as appropriate and predictable. Of course I won that because I know what I'm doing and this team was bound to win. They're a better team. And there's of course random elements, but they're discounted. We didn't really think that much about the random elements that might have led to winning. Whereas the losses were tended to be interpreted as flukes, atypical factors, and describing it as, I would have won except for this unusual thing that happened to happen randomly, right? So you can see here it's if you think that you expect that you're going to come out better, you think you're good at this betting thing, you can preserve that this way because here are these win ones. Oh, here I've got my consistent evidence, yes. And then these other ones don't really count because there's some random element. It was a fluke, it was unusual, right? So that's kind of what I mean about selective scrutiny. You could also do it in a scientific context. So here, if we go back to this, or actually any experimental study, you can imagine I've got a hypothesis, it doesn't turn out the way I expect. So first I did this and I'm still tasting sweet in the back and I'm tasting bitter in the front. What's wrong? So you could just say, oh, I've just bought into a myth and this whole thing is wrong. Or you could think, maybe I did it wrong. Did I not isolate the stuff properly? Maybe I need to try it again with different thing. Or maybe individual differences. Maybe I should try, maybe different people have different specific spots and that's why it didn't work. And again, this is something that isn't necessarily bad. If you research something that really is a relationship, if this really were true, you might have a failure where you got to correct the method. And in real research, this happens all the time where it's like, I thought this would turn out this way, it didn't. Sometimes there's things I did wrong designing the study. But then also, maybe it's not there. And if I keep chasing it, maybe I'm going to accidentally come up with something or not learn that I'm wrong. So it's a tricky situation. So kind of briefly going through, why is it hard to correct things that we personally and us as a culture think that are not really true? And it's not an easy task. There's some natural asymmetries in the information that can make it harder. These can lead to a false belief getting started in the first place, and then allow it to persist because certain things are going to stick out more. Our seeking information is not neutral. So like we're looking for examples. How do we do that with our brains? I'm thinking of an extrovert. I think, what are extroverts like? It's not a neutral process. So, and then if we run into things, even clearly seems to be wrong, that's not the end of the story, because we're pretty smart and can think of like, are there other ways to reconcile this with what I already thought? And you're going to naturally go through some effort there before giving up something, and not necessarily apply the same scrutiny to things that you just expected. I hope it convinced you that, and these are all, aspects of how our brains work. Part of what makes us do a good job, but it also makes it harder. We get started and think something that's true when it isn't. Now, what can we do to get over this, like as a community or scientifically? Cognitive factors can trap us in false beliefs. This is a challenge for scientific advancement, but the scientific methods and culture have kind of evolved to deal with these natural shortcomings in our intuition. So things like testing falsifiable predictions. That's part of the scientific idea. That's helping kind of against the idea of just looking for more confirmation, right? So part of the method that's evolved in our culture is helping deal with this natural tendency to maybe look at confirmation. Appreciation of randomness and use of statistics. Our intuition can be really bad about telling whether is there really a relationship, or I only notice these combinations, they stick out more. Your intuition won't work well. But now we're doing research, we're expected to take randomness into account, do analyses. We have peer review to help overcome biases due to us. So a lot of aspects of how science is done are ways that help counteract these, so that hopefully over time, we can actually learn the true things, despite the fact of how our brains tend to do this. So that's it. Thanks for your attention. If you want to know more about this one, I stole a lot of this material from a book by Thomas Gilovich, How We Know It Isn't So. And my class, I also teach material, say, from Dan Kahneman has a nice readable book for a broad audience and a lot of cognitive biases. Dan Ariely has a couple books that are readable. So if you found this kind of thing interesting, this is the kind of stuff I do in my class, and these are some of the reading materials that you might find interesting. Thank you.